Hey guys, welcome back. Now let's have a look over a new ADC, that's analog to digital converter, and it is MCP3425. And to gain more knowledge about this sensor, let's visit the website, that is controleverything.com, and here we have to search on for this sensor. As you can notice on my screen, it's MCP3425, and let's see what we got for this ADC. And as we see, it's a 16-bit one channel ADC, and these are some more features of this ADC, as you can notice on my screen. And this here is the section from where you can buy or add to cart. Alright, I will be interfacing the analog to digital converter in this video. Furthermore, MCP3425 with a particle photon and a photon code. The particle code is required to get that, and let's go to resource tab, and here comes the particle code sample. As you can see on my screen, you can download the particle code from here, right, as a zip file, as you can notice on my screen. And you can also get the code from github.com, and you can get it from the repository, that is Control Everything community. Now let's have a look over the hardware connections we need to put it together, and let's see how do we get that. Well, coming to the hardware connection setup part, the first thing we require, which you are able to see on my screen, is a particle photon. Now this here is an I2C Shield. It's available and can be purchased from the website controleverything.com, and the reason we are using this shield is to make connections easier with other I2C devices. So for that, what we require is to gently place this particle photon over the I2C shield and make a connection just like that. Now to power up this particle photon, what do we require is a micro USB cable, which you can see on my screen, and gently insert it over this power jack. Next, we require our analog to digital converter, that is MCP3425, and this here is a connecting cable. Now make the connection among the ADC and the cable, and make sure that the brown wire of the cable should be connected to the ground terminal of the analog to digital converter, and similarly to the ground of I2C Shield. Now we are done with all the connections for this hardware. Now let's have a look over the code. Well, now for the interfacing section, first of all we have to log in to github.com, and after logging that we have to check for the repository, search for it. It's Control Everything community, and then we have the sensor, the ADC exactly, which is MCP3425, and here we have the particle code. Now let's get back to the instructions part for the proper setup. As you notice, we have to log into a particle photon and set up the device, and the steps are on this link, which I will open right in front of you, so that you can familiarize yourselves with all the setup procedures, the commands, everything. Now in the second part, we have to download or git pull the code, and we have to copy the entire code on the online ID, and build.particle is the online ID where we have to create a new file. We have to paste the entire code there, and then we have to save it right here, just like that. And in the last part, as you notice, we have to verify and flash the code on the particle photon, and the code output will be displayed in the form of logs. Let's open up this dashboard link. We can see that the output will be displayed here, right from here. Now getting back to the code, it's a particle code, and the extension is .ino. And the code, as you notice, we have application.h and spark wiring I2C.h header files libraries, as you notice, and we have defined the address of the sensor, that is 0x68. Now here we have initialized and set up a variable integer value, and in the void setter function we have set some variables also, and we have initialized I2C communication as master with serial communication with a baud rate equal to 9600. In the writing section part, we are going to select the configuration command with continuous conversion mode channel 1, that is 0x10, and in the void loop function, as you notice, we have to read the data from the data register, that is 0x00, and from this very register we are requesting and reading 2 bytes of the data, that is, as you notice, raw ADC MSB, raw ADC LSB. After that, we have the conversion of the data, which takes place here, as you notice, which we have followed from the instructions provided in the datasheet for ADC, that is MCP3425. At the very end of our code, we want to display the output data onto the dashboard, which is the digital value of analog input. So this is how the code is. Now let's have a look over the working part. Now regarding the interfacing and the working, now we need to copy this entire part, the particle code, and now we need to open up the build terminal for the working part. And here, as we have discussed in the instructions part, we need to create a new file, as you are able to see on my screen, and let's name it MCP3425, and after that we need to save it, and then we need to verify it, and after that after the verification, it's a great work, as you know, and we need to flash the code. While flashing the code, we need to check for the magenta flash, which confirms that code is good to go, and we can have our successful notification on the flash right here. After that, we need to open up the dashboard link so that we can have our output onto the screen. Let us open that, and as you know, we have the digital value of analog input, which means there is nothing connected and the wires are on ground state. The value is 0, it's constant. But instead, when I try to connect a AA battery of 1.5 volt, as you see, it's a constant coming right now. The raw value will be 1107, and it's constant coming because we have a battery connected, and it's a standard potential value which you are able to see on my screen. So this is how the sensor responds. Now let's have a look over the applications and the features. The MCP3425 is a single channel, low noise, high accuracy analog to digital converter with differential inputs and up to 16-bit of resolution. The onboard precision 2.048 volt reference voltage enables an input range of plus minus 2.048 voltage differential. The device uses a 2-wire I2C compatible serial interface and operates from a single 2.7 volt to 5.5 volt power supply. The MCP3425 device can be used for various high accuracy analog to digital data conversion applications like portable instrumentation, base scales and fuel gates, temperature sensing with RTD, thermistor and thermocouple, and bridge sensing for pressure, strain and force. Well, you can have this sensor and you can purchase it from controleverything.com, and you can get the code from resource tab. From this site, you can download the code as zip file. Also, you can get the code from github.com, and the repository there is Control Everything Community. In the end, I would like to make it clear that if you have any doubt regarding any part of this sensor or video, you can have your queries on controleverything.com, and you can post your comments on the community page on this website. For articles and blogs, you can have a look over on instructables.com, and to subscribe more video tutorials like this, you can have a look over our YouTube channel. In the end, I hope you enjoyed this video and had a good one yourself. Thanks a lot for watching.